We're going to talk about Misconfiguration Manager again. We presented this last year at Troopers, so it's great to be back. We know that we're the last talk, and we are standing between you and beer, and we've learned not to get in between Germans and their beer, so hopefully it's not too painful for you. My name is Dwayne Michael. I'm a managing consultant on the adversary simulation team at SpecterOps. SCCM-wise, I have contributed some code to the Sharp SCCM project. I'm one of the primary authors for Misconfiguration Manager. You can find me at Subatomic on all the things.
And I'm Garrett Foster. It's my first time at Troopers, so I'm pretty excited to be here. I am a senior security researcher over at SpecterOps. As far as SCCM goes, other than the Misconfiguration Manager, I'm the primary author of SCCM Hunter, and then socials are at unsigned short. So.
And then we also want to introduce Chris Thompson. He is the third member of our Misconfiguration Manager team. He cannot be here this year, but he is instrumental in the project and everything that we've done. So we just want to make sure that he gets the credit he deserves here. So he's also a researcher at SpecterOps. He's the primary author of Sharp SCCM and Maestro, and again, one of the primary authors of Misconfiguration Manager. His handle is Mayhem at all the things. All right, so just to cover a quick agenda, what we're going to talk about and what we're not going to talk about. So again, we presented this last year, the initial release of Misconfiguration Manager. So we're going to start with kind of a summary, what has been done over the past year. It's been a year of Misconfiguration Manager, so cover what's been done in the community, the contributions that have been made, and then we're only going to highlight a few small subset of techniques. We can't cover everything. Even if we had a 60-minute talk, we wouldn't be able to cover everything. And then we'll cover some highlight all of the community contributions, and then if we have time, we'll take some Q&A. We will not cover walkthroughs of all of the techniques. We won't cover defensive and remediation walkthroughs, but they are all in the repository. And then, again, everything that we talk about will not be comprehensive, but it will be on the repo itself. All right, so who's familiar with Misconfiguration Manager to some degree? Sweet. All right, it's good to see some hands there. That was a little nervous. So for those of you that are not familiar, Misconfiguration Manager is a project that we released last year. Basically, it's a central repository of all known SCCM tradecraft, as well as defensive guidance for that tradecraft. So we really wanted to capture everything that was being done in that space and put it in a centralized area that everybody could access it. So it covers all offensive tradecraft, but also defensive stuff such as detection and mitigation guidance. And then we also have a PowerShell script called Misconfiguration Manager.ps1 that simply audits for most of the misconfigurations. So if you're a sysadmin or SCCM admin or something and you want to check if your environment is vulnerable, you can use that script to audit it. All right, so where we started. We kind of introduced a lexicon to describe some of these attack techniques. So you'll see the names up here. So we have takeovers, recons, creds, elevates, etc. So takeovers are basically when you can, a method to take over the SCCM site or hierarchy. Recon is enumerating information about SCCM or using SCCM to enumerate further information. Creds are credential access techniques. Elevates are privesks that don't necessarily lead to a hierarchy compromise. And then execs are execution on SCCM clients. The defensive techniques are prevents, detects, and canary. Pretty self-explanatory. So last year, when we released the initial release, we had 9 takeovers, 5 recons, 5 creds, 3 elevates, 2 execs, 22 prevents, 5 detects, 1 canary. So pretty big project. But even at the time of that release, we knew that there was a lot more. We had a backlog that we were working on immediately. And so over the past year, Garrett, Chris, and I have added more to it, as well as the community. So now we have a new takeover, which we'll tease later. We have 2 recons, 3 creds, 2 elevates, 3 execs. We added a new coerce category for authentication coercion, NTLM coercion. And then 3 new coerces and 6 new detects. All right, so we've been up to quite a lot. We've added quite a bit. But before we dive into the first technique, we kind of need to do a recap of Takeover 1. So has anyone used Takeover 1 in a real environment? Okay, a couple hands. So I would say, Garrett can back me up on this, we probably see this in every single SCCM environment. It's very rare to not have this attack path available to you in an SCCM environment. So Takeover 1 is when the SCCM site database resides on a host that is not the site server. It's on its own standalone host. And by design, the primary site server and the SMS provider roles have the DB owner role on that site database. So if we can coerce one of those two systems, either the primary site server or an SMS provider, coerce NTLM authentication from one of those systems and then relay it to the site database over MSSQL, we can grant ourselves the SCCM full administrator role by modifying the RBAC admins table. That table is just a table within the database that has all of the SCCM admins. So that's a recap of what Takeover 1 is. But there was a problem. So when you do find Takeover 1, it allows a privask from domain users to hierarchy compromise. So you can take over the SCCM hierarchy from a fairly low privileged context. The issue was, how do you find that remote site database? The way we originally had to do this was pretty janky. We were relying on things like, where is there an MS-SQL spin assigned to a host that has SCCM in the name? Not the best way to do it, but it worked in most cases. Until one day in the Bloodhound Slack, a guy named Dylan Bradley, who I had not known before, but he came up with this new technique that we did not know about, and it's actually really great. So we've named it Recon 6. He contributed this pull request to the project. So the primary site servers and distribution points create this registry key in HKLM software Microsoft SMS. And then in the local security policy on those systems, the policy sets these this key and its subkeys as readable. So regardless of the DACL on those keys, you can read these registry values over remote registry. Within this key is all of the SCCM site information, things like the site database. So by just querying the registry on one of these systems, which any domain user can do, you can find that, that site database system, and now you have your relay target. So Dylan, he weaponized this in a tool called PSS Recon, which I have linked here in the slides, and Garrett also added this into SCCM Hunter. So now I'll show you a quick demo of what this looks like. So this demo is going to show just that step of going through Recon 6 and then leading directly into Takeover 1, showing you how easy it is now without having to go through the janky service principal name lookup that we used to have to do. So first, we start here by showing you that the only SCCM full administrator is an account called domain admin. Then we'll use SCCM Hunter to profile the site server. And here we can see that we're going to query the remote registry on that site server. We find that there is a remote site database, in this case called SCCM-SQL. And then using SCCM Hunter, we create the stacked SQL query that we will use with NTLM Relay X that will ultimately add an account that we control as a full administrator in the site database. So now we set up NTLM Relay X, and then we coerce NTLM authentication using something like Petit Patam and relay that authentication to the remote site database. And now you can see that we now have domain user added as a full SCCM administrator. So the impact of an attack like this is, many environments will use SCCM to control all assets, even tier 0. So if you have domain controllers or certificate authorities, anything like that, that are SCCM clients, through Takeover 1, you now control all those Tier 0 assets. And we see that all the time. It's very common. All right.
So last year we talked pretty heavily about all the various credentials that you can pull out of SCCM. Probably the most familiar for all of you is network access accounts, and probably after that, the client push installation. It turns out that when we were first developing the project, my role was to just make every account possible and see if it was if we could pull it out of the database. And so during that whole process, there was references to something that Adam Chester had come up with, and then originally Benjamin Delpy, of being able to decrypt the credentials that are stored in that database. So if you're not familiar with the SCCM database, it's essentially the source of truth for everything configuration related, cryptography related, all the credentials, all of that data is going to be stored in that location. So it became this kind of blocker where you would need to have access to the database to be able to dump the credential blob, and then you'd have to have access to the site server to be able to run code on that, because the encryption certificates are stored locally on the CSP and can't export them. So it was useful, but it was difficult for us to weaponize. So I wanted to find another way to be able to do that, and it turns out that you can do so through the Administration Service API and therefore WMI. So if you're unfamiliar with both of those, the Admin Service API is just kind of like an intermediary of communicating with the site database. So it's a REST API that will transform those types of methods to WMI methods, which actually just talk to the database. So everything's already there. And it turns there's many more credentials that we weren't really aware of at the time. I published a blog a few months ago about discovery accounts. So there's various different accounts that you can set up for just discovering certain principles. So if you wanted one account to be responsible for looking up users or groups or systems, but you can also set up forest discovery. So yesterday Jonas had talked about kind of like traversing a trust boundary of an external trust using SCCM, and that's what he was referring to, is we can set up these accounts that are in a separate domain that we have no association with whatsoever, and kind of query information from there, and then be able to install the client and manage that domain without having it have a trust relationship established. You can also have site installation accounts. So if you don't want the site server to have admin over everything, which is something that we've kind of talked about at length, you can set up a service account for that. But probably the most interesting to those of you here is that Azure application co-management. So he mentioned how common we see SCCM. For me, my experience is that every operation that I had run since I joined Spectre at least had SCCM in it, and it was leveraged to do some type of objective. And most of them have this configuration. So when you set up co-management, you will register a client and application, a client and a server application in Azure, and that's how you're going to authenticate and grant the ability for your Entra users to authenticate to SCCM. So the key thing here is all of these credentials are stored in the database, and we can now extract them through the API. It works through WMI too. We haven't really got that done yet. Just have to trust us on that one. But let's kind of walk through that. So the scenario here is going to start off with you have done Takeover 1, you are SCCM admin. So now let's pull all the credentials out and get the plain text for those. So we'll go ahead and authenticate to the admin service API with SCCM Hunter and list out all the commands that we have available to us now. So there's a bunch of different credential extractions. I actually have to add one more later, which I'll talk about in a little bit, but I'm actually covering up that piece. So the first command that I ran was get creds. So that's what you're familiar with, pulling everything from the SC user account table, and that's your NAA, your client push installation, things like that. The second was get Pixie password. So the Pixie boot password, if it's configured, we can pull that out. And then the last one was the get Azure credentials command. So we're pulling out that server application, and we have that secret. So decryption is relatively easy. You do have to have some type of code execution on the site server. So you'll just call the decrypt command, paste that blob, and then you'll run a script on the site server, and you'll get the plain text information back. So that is kind of the gotcha, is that you have to be able to have some type of code execution on the site server. So far, we haven't found a way to leak the certificate for that. They have gone out of their way to make that difficult for us to do. So, but accessing the credentials now is a little bit easier. We did want to call out one more thing. CRED 1. So if you're not familiar, essentially what that is Chris Panay in DEF CON 30 published a talk about where he published a tool about Pixie Thief and talked about pulling credentials out of the task sequence process when you're doing operating system deployment. And we labeled that CRED 1. And a blocker for that for us was that you had to have some type of network access to be able to use UDP. And when Adam Chester joined, that was something that we were complaining pretty heavily about. And if you don't know Adam, you say something's a problem, it's difficult, and it's a good way to snipe him to do something for you. So he took it on himself to try to find a way to get this done, and he actually was successful with it. And he published a tool called cred1.py, and this essentially allows you to do the Pixie boot spoofing through C2. The caveat is that your C2 will need to support UDP. So I know Cobalt out of the box supports it, but there are others that do it. I know like there's some off-the-shelf proxy clients that'll handle that. But just wanted to make you aware that you can do CRED 1 through C2. It is possible, so you might want to add that to your toolkit.
All right, so the next technique that we'll talk about is using config manager remote control. So SCCM has this remote control feature. It's basically RDP, so you can RDP from the site server to an SCCM client, or you can shoulder surf users. Basically just a different way to RDP to SCCM clients. So this is viable as a standalone tool. It only really requires admin on the SCCM client itself, so you don't have to be SCCM admin. You could use this as a lateral movement method. The settings are also controllable locally or as an SCCM admin. You can make yourself invisible to the user that you're shoulder surfing, and it has a shared clipboard. So you can do some pretty cool post-exploitation with config manager remote control. We actually named this exec3, so because you can use this to get code execution on a client, but you can do some really cool post-exploitation and give some users heart attacks if that's your thing. So like I said, it requires local admin on the SCCM client, or you can do it from the SCCM server side with SCCM admin. This was blogged about by Chris Aw, and he wrote like a standalone VNC client for this. One of the caveats with that is that tool, since it's a VNC client, it doesn't have the shared clipboard functionality that for PostX we're probably pretty interested in. So using remote control provides a stealthy way to do some recon or some credential access. Again, you can make it invisible to the logged on users. So you can shoulder surf a user and they'll have no idea. And so, you know, for example, if somebody pops open their password manager and copies a password, you could use the shared clipboard to take that password out. So I think, do you want to add?
When we get to it.
Okay. All right. So just to show what this looks like, this is a screenshot of what it looks like when a user is logged into an SCCM client and somebody is shoulder surfing. So you can see there's a banner at the top. There's this whole message here showing who is viewing the session. But again, these settings are all configurable. So on the SCCM server side, you can change all these. You can choose to not prompt the user. You can choose to hide the icon on the taskbar. You can choose to hide that banner. You can also change these directly on the client themselves if you wanted to use this directly for lateral movement without going through the server. So then here's what it looks like without that. So as you can see, it's just a desktop, and there's no indication of somebody shoulder surfing. So if you're just doing this with a regular user, that they're not going to be any wiser to the fact that you're doing that.
So kind of a little bit more colored commentary about this one. We were doing an op last couple of days of the assessment where our POC was like, okay, you haven't stimulated the blue team enough. So I was like, I got something for you. Let's give this a shot. Lee Christensen kind of put me on this path to begin with. So the idea here was we wanted to get this execution method done on an actual user account and see what we could do with it. So we set that whole thing up, got access to the user. I specifically chose a VDI just in case they panicked enough and they like try to poke it in the eye and try to turn it off. So we hopped on. We actually had this remote session connected. They had no idea we were there. We were there for about 45 minutes. When we first connected, they were on a Zoom meeting. So we just kind of let that be for a little bit. kind of an interesting feature with this is that you have a shared clipboard. So anytime he would go to his password manager and use something, I would just paste in a notepad on the next screen, and I would have whatever he was pulling out of the password manager. You also have the capability to lock the keyboard and mouse and prevent any kind of use from that. So we waited till his Zoom meeting was finished, kind of waited to see like if he was doing anything else, any new processes were opening up, and it seemed like he wasn't there anymore. So we wanted to use his currently like running Ubuntu console that he had because he was an AWS engineer. So we locked the keyboard and mouse, started doing things, popped open stuff, started trying to deploy an EC2 instance, and he about had a heart attack. So he called their IT saying, hey, hackers are moving my keyboard and my mouse, and they didn't believe him. So he had to FaceTime them to show me typing in the Ubuntu console to convince them to turn the VDI off. So it was a good exercise for them. I think they shut us down in about 16 minutes, so not bad for the actual incident happening, but it is pretty cool. It's definitely a relevant technique. I know I've used it to get rid of word fault messages before the user showed back up. Turn those off. Okay, so the next one we wanted to talk about is Elevate 4. So who here likes ADCS certs and abusing those? I'm sure everyone, right? So SCCM has the option to support PKI, so you can get all the ADCS configuration set up there. So this is originally found by OnSecFR. It was a issue added to Chris Panetti's Pixie Thief repo. It's like, hey, is this normal? Like, what's going on here? I pulled a certificate from the Pixie boot process, and I'm the distribution point for some reason. And all of us lost our minds. We all freaked out about it internally, and then it kind of just disappeared, and then he disappeared. So we dug into why this was the case. So if you're setting up that co-management thing that I had mentioned, PKI is a requirement. So you have to set up some type of PKI. It doesn't have to be ADCS, but that's like what they suggest. So in order to set this up, you have to have the server and the client certs. So you're installing your server cert on all of your endpoints that are going to have HTTPS, so your management points, distribution points, et cetera. And then the clients that are authenticating to it are going to need a client authentication certificate. However, we're going through Pixie boot. It's not a client yet. It doesn't have any type of authentication. So what is the solution? The solution from Microsoft is to generate a client authentication certificate for your distribution point and then just loan it out. So you're going to import that cert and then pass it out to every single operating system that's doing a Pixie boot, and it's going to use that client authentication certificate to talk to its management point to pull down those Pixie policies that we can pull the creds from. So they claim it's only used during the OS deployment process. They say it's, they suggest, to simplify your deployment, you can distribute this to every OS deployment and have no concern. But we know better. So essentially the attack path here could be, like the worst case is no Pixie password equals 0 to hero. So if you have network access, you have nothing, and you're able to spoof a Pixie boot process, and they don't have a password protection on it, you could at least get the distribution point, or at worst, the SCCM site server if it's a standalone deployment. So pretty risky. So we have a demo of that to kind of show you kind of how simple that process is. If you haven't used Pixie Thief before, strongly encourage that. So we'll run the SMB command to profile distribution point. So you'll need a target. So you can try to poison the network or interact with DHCP to send the DORA to start this process. Or if you know of one that exists, you can just point it at that and go. So we'll pull that down. We've got the actual target. I need to move the screen. So Pixie Thief had pulled it back, and you'll see that it takes the SMSTS media PFX file. That's the certificate. And that was the one that triggered that issue to be published. So we can inspect the cert with OpenSSL. We see that it's a Microsoft certificate template. We understand that, like, what that means, and then it's used for client authentication. So because it's distributing the password during that deployment so that it can use it to pull those task sequences, we can just reuse that cert and that password to then compromise whatever system it's been used for. So in this demo, I showed the worst case scenario, which is just a standalone single deployment, no remote anything, all the roles on the site server. So if you're using Pixie boot on your site server alone, it's likely this cert, and now you have SCCM admin from nothing. So, but that's not it. It kind of goes a little bit further too. So any operating system deployment images that you're creating, so .wims.isos, and you're distributing them out as packages, you can use Cred6 to kind of interact with the HTTPS endpoints and pull those down. So if you're going over SMB, you can pull the WIM files down, you can extract those, and then kind of go through the same process of authenticating to, and then to the management point, pulling down the certificates and being able to auth as that. We say you need to have authenticated context, but we have seen anonymous access set up before where there's just no requirement for credentials whatsoever out on the internet where they have site systems just published out there where we can interact with them without credentials and pull these down and then recover those. I also recently, just like while I was here, was poking around and found that if they distributed the package to clients, if you've ever been on an SCCM client, there's a self-service software installation. There's another tab that's operating system installation, so you can start that process and actually have the image distributed to the client that way, and then probably pull a cert from there. So haven't investigated yet. It'd be cool if someone was able to confirm that. Community stuff? Cool.
All right, so I mentioned earlier that we've got a lot of community contributions over the past year. So Garrett just wrapped up the 4th technique that we highlighted. Like I said, we can only cover a couple during this short talk, but there has been a lot of community contributions, and so we just wanted to explicitly call everybody out, just because it is very important to us. We wanted to generate community interest and take this beyond just the small team of us at SpectreOps. So first of all, we have Josh Prager, one of our colleagues, who added a ton of detection guidance. He also did several talks on this, one from SoCon last year and one at SoCon this year, and I think some other conferences as well. So he has done a lot of detection work for SCCM, pretty much great resources if you're looking to defend against the techniques that we've talked about. Another one of our colleagues, Diego Lomolini, he originally contributed Recon 4 to the first release last year, and then more recently he contributed Coerce 1, which is coercing user context NTLM authentication using CM Pivot. And then Adam Chester, as Garrett already mentioned, created the Cred1 Pi, which gave us Cred1 over C2, which was a huge contribution as well. Alberto Rodriguez and Eric Hunstad created Cred6, so they submitted a pull request to cover distribution point looting, finding secrets in distribution points. Marshall Price added Detect 4 and also wrote up some blog posts about SCCM Tradecraft as well, so those resources are all listed on the repo. And then Recon 6 was Dylan Bradley, as we talked about earlier. So, and we also know that there's a lot of other people out there working on this stuff that we maybe don't know about yet. We try to stay on top of it, but there is a lot of stuff happening that we don't know about. So for everyone that's doing that, we do appreciate it, and we would love to contribute. So I think we're going to wrap up with one more technique, teaser.
Yeah.
So I'll give it back to Garrett.
Yeah, so originally I was just going to drop an O-Day because I was in my feelings a little bit about this disclosure, where we'd published it and then they came back and said that, hey, we're going to fix it. We want you to wait 30 days. It's like, we're going to give you 45 points, but it's out of scope. And we're going to say it's, what they say, it was spoofing and like important. So essentially, takeover 10's coming, depending on how long they take to fix it and whether or not they actually finish the review process. So it's not an elevation of privilege to them, it's spoofing, so that's fine. We actively exploited it. We used it to take over an actual on-prem, their on-prem AD, and then pivoted up into Entra and own Entra too. So out of scope, but yeah, I took the advice of someone that's a little bit smarter than me to not drop a no-day today, so sorry. As far as the rest of the work goes, so we say Microsoft is collaborating and taking it seriously. They are. I talked to a friend of mine who has some friends with MSRC, and they said that in the last 6 months they've had more vulnerability reports than they have in the last 6 years associated with SCCM. So there's attention on it. That means the community is actually contributing. So that's really cool to see. There's a lot more work to be done. I think it was 2 weeks ago at ZeefCon that Synactive, they published some work that they had done with SQL where instead of running commands through the API, they're just doing everything from the database, which is a really cool idea. But we want to hear more. We have an internal Slack channel or a public Slack channel where everyone's contributing and bringing ideas in. So please come share your war stories. We don't get to do it a lot, so when you're using these things and you share it with us, we can live vicariously. If you want to join us, the Slack is right here, that ghostly.ph Slack. So come hang out with us and talk SCCM. I think that's right on time. But yeah, thanks you guys. Appreciate it.